So I'm going to start by making a table on this here, sort out the information. So our N is our counter, and then here we have population of beetles. And mostly we start off counting at 0, and we got to keep track of that. And sometimes we call 0 the first period, even though we start at 0, just like when, you know, a kid, their first year of life, right? They're not 1 year old yet. So then we have 1 year later, 2 years later, and so on. So starting with 3 beetles, they're jumping to 4 weeks later. So 1, 2, 3, 4. The population becomes 51. So they jumped over here. 1, 2, 3, 4 times before they got there. So I need to know what number did they jump by here to get down there. So to get from 3 to 51, they made 4 jumps, right? 1, 2, 3, 4. So to figure out that repeated addition part, I'm going to have to back up and calculate it. So I'm going to take my 51, take the 3 off because I can get from 3 to 51, and that happened 4 times. So that's 51 minus 3 is 48.
Yes.
Double check my calculator, divide that by 4. 4 goes into 4 once, 4 goes into 8 twice. It looks like the repeated addition is 12. So just check that on the calculator quick. So what's the calculator? Right here. All right, so division of 51 minus 3 over 4 gives me 12. And again, always be careful when you're using a calculator that it does what you want. Like if I instead did type 51 minus 3 and then divided by 4, that screws things up because the divide by 4 didn't end up in the right spot. All right, so use your calculator wisely. This was the correct way to type it, not that. So that should be that repeated multiple. Just to double check, let's see, 3 plus 12 is 15. 15 plus 12 is 27. 27 plus 12 is 39. And 39 plus 12 is 49, 50, 51. Yeah, it works out. Okay, so good. I got that right. So as far as my explicit formula goes here, is I'm starting, it always goes start plus whatever your repeated addition is times n. So that would be starting at 3. I want to add 12 however many times I need to. So that would be one way to type it in there. Or you could type it like a linear equation, and that would be the same thing as saying 12n plus 3. All right, next. After how many weeks will the beetle population reach 315? Okay, so they're not saying, look, 350 weeks in the future. When will there be 350 beetles? So I have an equation that says the population at some time n is equal to 12n plus 3. I want to know when that will be equal to 315. So to solve this, I'll unwrap to get to the n. Right? If I knew n, I multiply by 12, then add 3. Since I don't know n, I have to get rid of the 3 first, right? Kind of like I did up there. 315 minus 3 is 312. Double check that on a calculator. 3 minus 3 goes away, that's 0. 0 plus 12n is 12n. And then I can break that multiplication there by dividing by 12. So n equals whatever that is. Let's double check. And again, you might say, why would I check 315 divided by 3 minus 3? Like, my brain does weird things under stress. So test, double check everything. All right, so there's my 312. And I want to take that previous answer and divide it by 12. And I get 26. What a nice number. Now, they don't always work out to be nice numbers. So if you get a weird number, that doesn't mean you're wrong, but you should double check it. Okay, so I think mine is 26. So this equals 26. So that would be 26 weeks later. There will be 315 beetles. To double check that, because if this is a quiz, I don't want to hit that submit button until I'm sure of what I've done here. I would just plug back in. So I'm going to check. So it is 12 times 26 plus 3. Calculate time. 26 plus 3 is 315. So it looks good.